some of you did the Khan Academy already. That's great. So today you'll just have to do just the notes and then just look it over. All right. On the pace, I did add a couple of notes on here. And that note is that late work is not late. So I'm just gonna take all work, and you gotta have everything done. You can't give me these really simple, half done notes. I'm giving you all the points for everything, so you gotta do your part. Okay. Uh, and also, do not share your picture of your notes with other people because that's not cool. All right. All right, so let's get to this part. All right, so let's come up with two functions. One of them will be an absolute value and one will be a quadratic. They'll look really similar. And let's start off with f. F is the name of a function. And let's make this one be 2 times absolute value of x minus 3 absolute value minus 4. And then the quadratic version will be the same thing, except it's going to be g. This is a different function. And this would be 2 times x minus 3 squared minus 4. Okay, so let's graph both of these and see how similar they are and what's different about them. Okay, so I'll give you a second to catch up. I know that I had cheated. I had written the heading before you guys did. And also take a look at your notes from yesterday. And let's have people interact, because the more of you interact, the better. What is the first step that from my advice when you graph? Find the vertex. And before you even do that, you need to imagine. You should already kind of imagine that this is going to be a parabola shape. So you should see that and recognize. You can say, oh, it's a square. It's going to be a parabola. And then the other one is going to be a V shape. Okay, V-ish shape. Sorry about my mess here.
I have a question.
Of course, go ahead.
So the difference between like the V shape and then the parabola is the parentheses and then the lines, right?
Exactly. So you want to like recognize that, right? Now, if you didn't know that, you could still graph it, but you would kind of be shooting in the dark and you'd be just plotting a lot of points, right? But if you already knew that, then you would already be you'd have half of the battle done, right? So the difference between a quadratic and the absolute value is the this is the line, right? And it's kind of a giveaway. Look, these are straight, and then these are curvy. I don't know, maybe it could be some way to remember. Okay. All right. So the first step is find vertex. Find vertex. And that is not the only way to do that. That's just my tip for you, like my technique, right? All right. And question, and anybody can answer, whether it's through the chat or just shout it out. How do you know the input number? Which x causes the lowest point on these parabola or quadratic? I mean, quadratic or absolute value. Which input will cause the lowest number to show up? Okay, all right. Hayden says 0. That is pretty close. Okay.
Would it be +3?
Yeah, +3 will actually cause 0 to happen, Hayden, right? So what you want to do is, and I'm going to do this, and you're not going to be able to do this, what I'm going to do, but you want to take this out. You're not going to be able to do that, but you can just write it, and you can say, oh, that needs to equal 0. That needs to, one second. I'm going to get better at this. That needs to equal 0. And what am I going to do for the other one with the quadratic? The same thing. I'm going to get the inside and take it out, and I'm going to say that needs to equal 0 too. Okay. So, all right, that is going to equal 0. So, plus 3, right? Obvious, you can tell that x equals 3, and over here is the same thing, right? X equals 3. So, x equals 3 is the x of vertex for both of them, right? So the vertex has two parts. It has the x and the y. So now we know the x, which is 3. All right, now, what do we do with inputs? Anybody? What do we do with inputs? What do we do with inputs?
I don't understand the question.
So what do we do with this number, with x equals 3?
That's going to be the vertex.
That's going to be the x of the vertex, right? Part of it,
Yes.
right? So now we need the what?
The y.
The y.
So that would be 0.
How do we get the y? Where? I'll help you guys out. You plug it in. You plug the 3 there. So you plug it in. So inputs, you input them. That's kind of what I was trying to get to. So you input a 3 in for x. And then, now, this is going to be a little silly to do all this work, but you got to try it. What's 2 times 0? So what is the y? The y is -4. So now we know the vertex. The x is 3 and the y is -4. So remember that the vertex is two parts. It's the x and the y, okay? Now, to find out the x, you got to set it equal to 0. And to find the y, you got to plug it in, right? You can write yourself a note. Plug it in. Now, you're going to get 0 here because that's why we picked 3, by the way, okay? All right, so what are we going to get in the other one if we plug in a 3? If we plug in a 3 for x. Now, like I said, this is going to be a lot of work, but it's really, you're at the end, you're going to know this is going to be the y. So we're also going to get a vertex of 3 comma -4. So they both have the same vertex, okay? All right, so now we can start our graph. Okay. And I messed up on the colors. I should have kept them black for the absolute value. And all right, so here's my xy. And it's going to be 3, -4. So 3, 1, 2, 3, 1, 2, 3, 4. Okay, that's my vertex. All right, and then for my quadratic, it's also 3, 4. So I'm doing both at the same time so you can see the similarities, and also you'll see the differences too. Okay, so 3, -4. Okay, and now what's step 2 for our, wait, hold on, 3, how come one of my graphs doesn't look the same? 1, 2, what's step 2 from your notes from graphing? Anybody have?
3 instead of 3.
Yeah, let's see. All right, so we can make a table, right? Make a table. We know that 3 caused a negative 4. So now we can just plug in a different number like 4 or 2. So which one of these numbers would you like to plug in into the equation? 4 or 2? Anybody?
4.
4. Okay. So let's plug in 4. Now, I can't remember the equation. I got to look up 2. Okay. So you're going to plug in right here into x. You're going to plug in, you guys said, I forgot what number you guys said. 4? I think you said,
4.
yeah, 4. All right. So you're going to plug in, instead of x, you're going to put 4. So you're going to have 2 times the absolute value. 4 minus 3 is 1. Minus 4. This is 2. Minus 4. This is negative 2. So this is the answer right there.
Can you move it up? We can't see it.
Yeah. There. It gets a little bit blurry there. Okay. And so we plugged in negative 4 and we did the math and our answer was negative 2. So that means this is the y. And it would be the same for the other side of the vertex. Okay. So how now we can just graph this one. Oh, I know why I messed up on this one. On this one this should be, that's why it looked off. Let me erase something. All right, so now we can graph this absolute value. Okay.
I have a question.
Yeah.
So on your x and y table, there's 4 and then negative 2, and then there's 2 and negative 2. So how come they're the same?
So when we did absolute value the last couple days, we found out that if you know the vertex, let me draw a little person. Let's pretend. Give me 1 second. Let's pretend the vertex was here. Just pretend was here. That's the vertex. Then from there, we found out that from there we're going to go up 1 over 1, our little steps. And then we also did the same thing to the opposite side. So these y's are the same. So this y is the same as this y. This y value is the same as that y value. And this y value is the same as that y value. So if you know one of them, it'll be the same as the one right next to it. Now you can actually prove that by plugging in 2 on the equation. Okay, does that make sense, Amar? So
Yes.
I'm kind of cheating a little. It's just because I know. See, you got to know that. All right, I know this. I know that they're symmetrical. So I joke that I'm lazy, but I'm not really being lazy. I'm just being clever, right? So let's graph that. Let's graph this one. 4, negative 2. So 1, 2, 3, 4. 1, 2, 3, 4, negative 2. Now, are the steps the same size or different size on absolute value? You guys wrote that in your notes yesterday. You did little bubbles and everything. I gave you guys 20 points if you did that. Are the steps the same size or different size?
Same.
Same. Oh, on absolute value, right? On absolute value, they are the same size, the same height. So if you know one of them, well, you automatically know the next one and the next one. So do you need to do any more math? And then remember, the steps are the opposite to the left and to the right. Okay. So then we have the data. So how much math did I do?
Just one problem.
Basically, I just found the vertex, right? Make sense? Okay. And then I plugged in 1. Okay. All right. Keep on asking questions, guys. All right. So on the quadratic, we are going to, first we started with a vertex, which was 3, -4. And we'll make our table. Now our table, we don't really have to do a lot of work because we know the vertex, V for vertex, is at 3, -4. So what number would you like to plug in? Because these are like mirrors of each other, right? So if you get one of these answers, it'll be the same as the one around the vertex. So would you like to plug in 4 or would you like to plug in 2? So which one? 2? Okay, let's plug in 2. So in the equation, or the function rather, we're going to plug in, you said 2. So we're going to plug in 2 here. And then that'll equal the y, right? So it's going to be 2. What is 2 minus 3? -1. And what's -1 squared? +1. And this is 2 minus 4. And this answer is -2. Y equals -2. So if you got one answer, that means you got the other one too. Okay. So far, it's the same as the absolute value because the absolute value is also the same point. Okay. It went up 2/1. Now in in quadratics, the steps are always this size. They go up 1, 1, 3, 1, 5, 1. This is the quadratic steps, right? Quad steps. How far did the first step go from here to here?
Yes, I can't see what you're drawing right now.
All right, let me zoom in. How's that?
Yeah, it's better. Thank you.
You're welcome. So the vertex is here, and on this one we went up 2/1. But normally we go up 1. But this time we went up 2 because we had to multiply it by what? 2. What's the next step we're going to multiply by? So what is 2 times 3?
6.
6. That means the next step is going to be 6 feet tall, right? Whoa, what happened? Hang on one second. All right, then that means the next step is going to go up 6. 1, 2, 3, 4, 5, 6/1. And that's going to be my point right there. All right. And what's the next? I might be able to graph the other one. What's the next step going to be? How tall is it going to be? What would it be? 2 times what? 2 times 5, which is what? 10. So it's going to go up 10. 1, 2, 3, 4, 5, 6, 7, 8. I'm off my graph. Okay. All right. And that's enough, right? To do a parabola.
I have a question.
Yep.
So you're adding 2 and then multiplying by 2?
No, we're only multiplying by 2.
Well, because you're going from 3 and then to 5.
Oh, yeah.
And then you multiply.
Right. So the quadratics, they're always going to do the what I'm going to circle? It's always going to be 1, 3, 5, right? But this particular quadratic multiplied all of these numbers by what?
2.
By 2. Okay. Hold on, let me see it. There we go. So this number out here, this tells you how much bigger. Let me zoom up so everybody can see. I know that. So this number tells you how much bigger the steps are. the normal, right? Normal, right? So the normal is 1, 3, 5, 7, right? But the 2 says, yo, double them. Double the 1, 3, 5, 7. Now the normal steps for absolute value is 1, 1, 1, 1. So the normal steps for the absolute value are normal, are up 1, up 1, up 1, up 1. And what did this 2 say to do to those steps? It said what? Double them, right? Double 1. So that means the steps are 2, 2, 2, 2. Okay. All right, next we're going to graph the other side. I graphed the left side, the right side. Now I got to graph the right side. So I still do my little thing, my little steps. 2, and what's the next one going to be? 6, and then the next one's going to be 10. Okay. Now I know it's hard for you to graph if you don't have a graph paper, but you're going to have to, at least what you should do is write yourself the numbers. 6, 10. Okay. And this graph appears to be stretched out more than the normal graph. The normal parabola looks kind of like this, but all of the y's got taller. See, all of these got taller, so it looks like it's skinny. Okay, so it's not really skinny; it's stretched up. It's double stretched. Okay, all right. So that's my little review of basic. We're going to spend a lot of time on this. Okay, so don't stress out. Just get the idea. Now, if you can remember this, what you could do is you could do a lot of math. You can plug in all kinds of numbers. How many numbers did I plug in, by the way? How much work did I do? Did I even use the table a lot? Now you could do the table a lot, so you could do that too. Okay. All right. So I'm going to do a couple of Khan Academies, but you don't do them yet. Okay. So I'm going to do them, and you take some notes on these. Okay. And then I'm going to stay with you as you do them. Okay. So number 1 says function g. So g is the pink one. Can be thought of as a translation of f, and f is the blue one. This is f. This is normal f. See, up 1 over 1, up 1, up 1, up 1. This is the generic f. Now it looks like g moved to the right 3 and down 1. So does anybody remember, is it plus 3 inside or is it minus 3 to move things to the right? To the right, is it up? Is it plus 3 or minus 3 inside?
Isn't it plus 3?
Yeah, so with plus 3, it actually moves it the left way. And write this down in your notes. Inside the parentheses, it's backwards, okay? So if it goes to the right, the inside must be minus 3. So it's got to be C or D, okay? Now it also moved down 1. Now down 1 is normal, and that would be minus 1. So that would be this one right here. So write yourself a note. When it moves side to side, it's backwards, sort of. I don't really think it's backwards, but it looks backwards, okay? All right, let's press that. Okay.
I have a question.
Yep.
So basically, if it's going to the left, it's adding, and if it's going to the right, it's subtracting?
Yes, write that down. So if it's going to the right, it's subtracting, and it's going to be inside the parentheses or inside the absolute value, right? Inside, okay? And a couple of days ago, I explained that it's not really backwards, but for our case, it looks backwards, okay? All right, so here is f, all right? F is normal, just a normal v, right? See this right here? I don't see f of x equals x. I see a v in my brain, okay? All right, and next, this one says, G says, yo, move it 4. So class, is this going to move 4 to the right or to the left? Is this going to move 4 to the right or 4 to the left?
4 to the right.
4 to the right, because it's backwards. Now this -4 is not backwards. Is that going to move up or down?
Up.
Up. No, remember, outside, when it's outside the parentheses, it's not backwards, it's normal. So,
okay, so down.
Down, okay? So only stuff in the parentheses is backwards, okay? So you said it's going to go down 4, okay? And then it's going to go to the right by 4, okay? Remember, and write it down in your notes. And I'll even give you guys an extra 5 points today if you give me, so this is what I want you to do today. So write in a little bubble and say backwards in the parentheses, and when you post a picture, like point to it with your finger, and I'll give you 15 points instead of 10, okay? All right, let's do this last one, and then I'll do one more with you. All right. Shifted up 7, left 8.
What are we supposed to write?
You're supposed to write inside the parentheses, they move side to side backwards. So if it says +5, it moves to the left, right? If it says -5, it moves to the right, okay? So put little bubbles like yesterday, okay? So you're supposed to say inside the parentheses, it moves side to side backwards, right? Backwards. Outside of the parentheses, it's not backwards. Outside is perfectly normal, okay? All right, this next one is going to say, and you can ask me again, and I'll repeat it in different ways. It says shifted up 7, so that's going to be plus, it's going to be these two right there. And it says left 8. So which one is left 8? So left, is it +8 or -8? Is it backwards? Left 8. So is it going to be +8 or is it going to be -8? Which one do you guys think? Left 8. Remember, it's backwards. So left is that way, which means it's plus, okay? All right. All right, let me try the other one, and then I'll let you guys practice, and I'll wait with you. All right, this time we're going to graph absolute values. Shift, let's see if it's this one. All right. Okay. Here comes. And I'll come back to the notes and I'll write down what I want you to have, okay? All right. Okay. This one says, which graph is scaled vertically by a factor of 1/3? Now, vertical is outside. So this is 1/3 has to be outside of the absolute value. So it's going to be this one right here. Vertical is up and down. It's normal, okay? All right. Choose the function of g. All right, so g is upside down, so that's going to be a negative, okay? And how would I know? So it's got to be this one or this one. Now, is this stretched or is it wider? So how can you know for sure? Okay, let me zoom in a little bit. Now it's got to be one of these two. So let's see. I'm going to plug in. Let's see. Which one of this is bigger? What's 5 halves? This is 2.5, and 2/5 is 40 cents. So this one got stretched, and 2.5 is bigger than 40 cents. I turned this into decimals, so definitely it's got to be this one because it's got stretched. It got skinnier. Okay, and I'll do one more. All right, which one is a scale factor of 7? Okay, so vertical. Remember, vertical stuff is normal, and this stuff happens outside. So this is going to be this one right here. All right. So can I have you guys try those out, and I'll wait for you. And you can also project your questions on you have to click present. Okay. So go ahead and go on Khan Academy and try them out, and I'll be here with your questions. Any questions you have. Okay. Doesn't matter. And here's the big thing. All right. So this will say moves side to side to the left. That way.
Is it 75% good or?
Yeah, 75% is good. Yeah. So remember, you get like a little extra credit if you try to get 100, but you don't have to worry too hard. How about that? Now, if there's a number outside, this is called a vertical stretch, which means the steps got bigger by three times bigger. Okay, so 3 times bigger, 3 times bigger steps. Okay. Here's another one. X minus 5. And the minus, does it move the graph to the right or to the left? And go ahead and continue your Khan Academy, all right? Now you can actually project your problem if you get stuck on one, and I'll help you through it, okay? All you got to do is click on the bottom and it'll say present or something like that.
Are we also working on the third Khan Academy today?
Yeah, is there? Yeah. Oh, I think there is a third one. Thank you. I thought I was 3. Is it the graphing one? What's it called?
Graph absolute value function.
Yes. Let's see. Let's that one. Yeah, I thought there was 3. All right. And that's actually the graphing one is the one I wanted to, because that's the one we've been really focusing on, right? All right. So here is a third one. If you want to take a peek. Oh yeah, this is the one I wanted. Okay. So can you guys all take a look at this one real quick? Look at my screen. Go ahead and pause your Khan Academy. This is the one that I really wanted to do. All right. This one, the vertex is going to be -2, -3. And how do I know it's -2, -3? Because what number can I plug in here to cancel out this 2? -2. All this is going to become 0. So what's left over? Okay. Now the next step, this says the step, it used to be 1, but now it's times 7. So that means my very first step, and I'm going to be going up 7. 1, 2, 3, 4, 5, 6, 7. And there's my graph right there. I'll do one more, and then you guys can practice, okay? All right, looks like I did. Let me press continue again. And I can never figure out how to get that continue button to show up again. Let me click on. And it's not Control Shift QQ, right, Omar? Okay. So on the graphing one, what I did, I found the vertex. And then the number outside told me how big my steps were from the vertex. Okay. Let me close this, see if it works again. Graphing. And this is the one I really wanted to do. Okay, so here's another one, okay? So the vertex is 0. And then if you put a 0 here, 0 times 6 is 6, so that means it's going to go drop to -4. Okay? And the number outside tells you how big the steps are. So it means go up 6 from there. So 1, 2, 3, 4, 5, 6. And there's my, okay. Claudia, was this helpful, the graphing part?
Yeah.
Okay, so this one, I'm going to go to -4 and then +3. And it says the steps are 4 feet tall. And each step is the same. So I'm just going to go 1, 2, 3, 4. How much math am I doing? A lot of math or more understanding? You know, this is the idea. Okay. All right, so everybody try it out and let me know how I could help you graph these.
Mr. Quinones, so I have this one. It says the graph of y equals x is scaled vertically by a factor of 1/3.
Yeah. So that one is, let's pretend, and can you? Yeah, can you project it? Let's see.
Yeah.
And that'll be this will be our first try of students projecting, and I've done it with my M1 class. That's why I know it works. I think you got to click present or something. There we go.
Is it working?
Yeah, it is working. Exactly. So on vertical graphs, well, you want where'd it go? Let's see. 1 second. It disappeared, but the 1/3 will be the size of the steps, and that'll be in the very front of the absolute value. Okay. Does that make sense, Amar?
I think yeah. So
the 1/3 will be in the very front of the bars.
Okay.
Okay. So vertical things happen outside of the bars.
All right.
Yeah, you were presenting and it disappeared. I don't know.
I think it's working now again.
All right, let's see. All right, is this now I still only see mine. Okay, but yeah, I did see it for a second, so it did work. All right. Anybody else have any questions? Keep on asking. That's why I'm here. I'm going to keep graphing this one. This is going to be it's going to be at 6. My vertex is going to be at 6 and then +2. See, if I put a 6 into x, this all turns into 0. This is all leftovers too. And my steps are 5 feet tall. So I'm going to go up 5. 1, 2, 3, 4, 5. So remember, you can ask me any question here. I'll do my best if I can see your screen, it'll help. And if I can't, you can just describe it and we'll figure it out that way. Oh, this is going to be 5, 5 -4. And the steps are -2, which means they're going to go down. All right. Anybody have any questions? Let me know. Okay. I'll do the scaling one. This is a scaling one, so it didn't shift. It just got stretched up. So instead of a step of 1, this step is 3, which means the 3 has to be outside, right there.
I have a question, Mr. Quinones.
Yeah. What do you got?
For the shift absolute value graphs,
Mhm.
I'm stuck on a problem.
Yeah.
I'm gonna see if I can present it.
Yeah, definitely. This is really cool. Let's see.
Oops, wrong button.
It's okay. The more we do this, the better we get at it, by the way. Okay.
How did Amar present this? I got no clue.
Oh, you think you click on the screen and on the bottom?
There should be a button with like 3 dotted lines, and then it says start present screen.
Yes, yeah. Move your mouse in the center, and then you have the menus that has the microphone and on the right side it'll say present now.
It has a pin on it.
A pin. The pin is in the center of the screen, so the menus will show up in the bottom, don't they? Let's see. Let me see how. Let me look at mine. How does it work here? I'll show you. So mine. See, I get this little menu.
I'm sharing my screen. I want this one.
Yeah, there you are. Okay.
Oh,
Yeah.
okay.
So
This is the one I'm stuck on.
yeah, I see it. So inside the absolute value is backwards. So when it says -4, that means the graph is going to go to the right 4. And
So-
the outside, yeah, so go ahead and put right 4.
And then this would be 4.
Yeah. And then the outside of the absolute value, it's not backwards, it's normal. This is down 4.
Oh.
So remember, and write this down so you don't forget. In the inside the absolute value or parentheses with quadratics, it works the same way. It's backwards. So if it says -4, it actually goes to the right. If it said +4, it goes to the left. And and then outside is normal. It's just up and down. Okay. All right. Let's see another one. Go ahead and.
Mr. Quinones,
Mhm.
I need help with this one.
Sure.
I can try presenting
Yeah.
again.
Yeah. Let me help you. Leave it. Oh, never mind. Okay, go for it.
There you go. Sorry.
Yeah. All right, so this one's going to go to the right 3, which means it's going to go -3 inside of the right. So it's got to be A or B, right? Now this one went down 1, and that's normal. Okay, that would be a normal -1 outside.
That'd be negative. It'd be B.
Yeah.
Okay. I get those ones.
Yeah,
It was
and-
just that other one that I was like,
Yeah.
let's
Yeah.
on that one.
All right, Amar, are you presenting, Amar?
I'm
All
trying.
right. Yeah. Go ahead.
Kind of weird.
There you are. Let's see.
It's kind of hard to use.
Let's see. There we
Okay.
go.
Can you see this?
Yeah. Are you using your computer, your phone, or what? Yeah, I see it. So go to Khan Academy.
I'm using.
There it is. All
Yeah,
right.
I'm on Khan Academy.
Good.
Okay. Yeah.
So let me see the graph real quick. All right. So look at this. The graph. It didn't move. It stayed at 0, 0. So the steps used to be up 1/1, but these steps are taller, right? Just a little bit taller, right? So it's the steps to get the pink are bigger, right? They're taller steps. Now let's look at the possible answers. Now look at this. C and D are wrong because they shifted the vertex up, right? Make sense? Now, which one is bigger, 4/3 or 3/4?
4/3 is bigger.
That's it. So the steps got bigger, so you know it's got to be A.
Okay.
Because if it was 3/4, that means the steps got smaller. They used to be 1 feet, now they're 3/4.
Yeah.
So you want to like analyze it, right? Did the steps get bigger or did they get smaller, right?
Yeah.
Totally cool. Yeah, this is really cool that I can see you guys work. Okay. All right, so go ahead and do the last one, the graphing one. All right, and this one right here, right? So what does the +3 tell you? That
So that it's like going to the left 3.
Yeah. So go ahead and take the vertex to the left 3, and then bring it up 2, right? And bring it up 2. No, the vertex. Move the vertex up 2. There we go. Now look at the size of the steps. See the 2 in the front? So that means each step is 2 feet tall. So then just bring the dot close to the vertex and then bring it up 2. There we go. So then bring it up 2 feet high. Boom, right there.
Like that?
Yep. Perfect. Does anybody else have any questions? All right, go ahead and try this one by yourself. Don't press check until I agree. Go ahead and talk it through if you want.
So it says +1, so we go to the left 1.
Right. And then you go down 1 because the one outside says drop it 1.
Yeah.
And how big are these steps?
8.
8. So bring that dot close to the vertex, right next to the vertex underneath, and go up 8 from -1, right?
Yeah.
Yeah, so which would probably be at 7. Boom, go for it. All right, this one, it moved to the right or left. There we go. Now it didn't, yeah, and it didn't move it up or down. See, there's no number outside.
Yeah.
And how big are these steps?
-2.
Yeah, they actually go down. Instead of up, these
Yeah.
steps go down.
Okay, so.
And that's why I like,
that?
yeah. And that's why I like the idea of steps, right? Because steps can go up or down depending where you're at.
Whoops.
Boom. Okay, one more. All right, where's the vertex of this one?
Left 3.
Yeah, and then what?
And then down 2.
Exactly. All right.
Okay.
And then how big are these steps?
Down 3.
Down 3. But make sure to make them one away from -3. So you got to move that step side to side. Yeah, right there. Because remember the width of our 1, right?
Yeah.
Perfect. You got this, man. Okay.
Cool.
All right. Anybody else? I think you got them all. You got 100% there.
I'm still kind of confused. Can you do another one?
Yeah. Let's see. Would you like to pick one and yours and present it, or you want me to show you mine? All right.
Show me yours.
All right. Let's see. Yeah. Let's see. I think it looks like you're gonna be. It's gonna be presenting right now. If it doesn't, I'll show you what the problem I have here. It looks like it's almost there presenting. All right. Anyway, so.
Because I got close, but then I would still be off.
Okay, no problem.
So I got like the vertex positioning right, but I wouldn't get the other dot.
No problem. All right. What do you think the vertex is of this function on my screen? So what number can I put in next to get rid of -5? +5. Like what number will cancel it?
Oh, +5.
+5, right? And then it says if you put a +5 here, all of this disappears, turns into 0. Do you agree with that?
Yeah.
And what's still left out here?
+1.
Which means the vertex went up.
Go up 1.
Okay. Now, this number tells you how big the steps are. How big is the first step?
3.
3. So from the vertex, go up 3.
Oh, okay.
Right? Now, I'm only going up 2. There we go. Now, don't go up 2 feet away from it. Go 1 foot away from the vertex. 1. Does that make sense?
Okay.
Because this is also 3, but it's over 2. I need it to be always over 1. Okay. All right. Let me do one more, and then you try. Okay. All right. What do you think the vertex will be here? What can you put inside of x to make it 0? 0, right? It's kind of a trick question, right? So this has nothing to change. If you put a 0 here, it'll get rid of everything here, correct?
Right.
And what's still here?
1.
1. So that means go up 1. Now, how big are the steps?
-8.
Which means go to the vertex, or go right next to the vertex. And instead of going up steps, they're going to be going down steps.
Down.
And there you go.
Oh, okay. That makes a lot more sense.
So if there's nothing inside of the absolute value, then that means it didn't move side to side. It stayed on the vertical axis. Okay. All right, try it out. All right, let's see. There's still people here. Anybody else needs any help? All right. People are dropping like flies. That's okay. That's good. That means they got it, right? All right. So I'm going to stay here until everybody's gone, and I'll stop recording. definitely don't hesitate